Okay, so people have been studying ozone. We had said Dobson units. You point the detector up and you see how many ultraviolet rays are making its way down to the earth, and you use this number to calculate how much ozone is present. And so for many years, people have been realizing that something was going on, that we were losing ozone. The Dobson units were falling. And now there are some natural interactions that happen with nitrogen oxides, can combine with ozone and all, but that's natural, and that hasn't changed in the last 40 years. Now, what's interesting, I'm old. I've been around for a while, and we're talking about like 40 years. Well, I'm older than that. So I remember back when I was growing up, if when you didn't buy roll-on deodorant, it was all spray can. Everything was spray can. So, Right Guard deodorant was in a spray can. There was refrigerants that used a certain compound as well. There was this compound called the chlorofluorocarbons. It's a mouthful. Chlorofluorocarbons. It's a mouthful, so they refer to them as CFCs. And it was thought to be a really safe compound. Why? Because it was incredibly inert. That means it doesn't react. And so it was thought to be extremely safe, so you could, spray on your deodorant and you didn't have to worry about it. And it was being used as a refrigerant, I think. There's a lot of uses for this very stable compound. Well, it ends up that this really stable compound, after about 5 years, it will make its way up into the stratosphere. And so we had said that area where we have the ozone. And we had said what produces ozone? It's interactions with this really strong ultraviolet radiation. Well, that ultraviolet radiation can break down these chlorofluorocarbons. They're incredibly robust and inert, but you hit them with enough radiation and they will break down. And so what they will do is they will break down and release a chloride radical. So chlorofluorocarbon, so they break it down and they release a chlorine from it, and a single chlorine from a single chlorofluorocarbon molecule can catalyze, I'm going to look at this, 1 times 10 to the 5th ozone can interact with 100,000 ozone molecules. 100,000. And that's from a single chlorofluorocarbon. And it then gets regenerated. The two pieces can go back together as CFC. And when they look at it, so they realized, they said CFCs are responsible. And so long time ago, just think about it. You don't use spray-on deodorant because they got away from this propellant before you were born. But we still have the ozone hole. You know why? CFCs last, estimates, 120 years in the atmosphere. So the propellant that I was spraying out of my deodorant can when I was a kid is still up there doing it. So, and it'll be destroying the ozone for a long period of time. So we realized, as a result of the work done by Rowland and Molen, we realized that the culprit, and the U.S. took the lead in eliminating CFCs, and then later on, worldwide, we have stopped using CFCs, but we've got about 80 more years before we can see any recovery from this. Now, the South Pole, gosh, your book goes into a description of why the ozone hole is in the South Pole. And it's because it's really, really cold. It is because it is really, really cold in the South Pole. And as a result of that, it being so cold, I'm making sure I'm still recording because my phone did something weird. Um, you get this vortex around the continent down there, and it becomes so cold that it makes it much more susceptible, or it produces some precursors for ozone that then interact in summer. And so in summer is when the ozone hole appears at the South Pole, but it's because it's more cold than even the North Pole. Okay.